Hello guys, in this video we will learn to predict car price using machine learning. So, we will understand our problem statement first. We have to predict car price of a used car. We have several information about those cars and this particular dataset contains car brands. So what is the brand of the car? What is the year of the particular model? And what price that particular car is sold, and the present price of that car, and the kilometer driven, the fuel type, whether it runs on petrol, diesel, or CNG, the seller type, whether the seller is an individual or a dealer. In the transmission, whether the gear system is automatic or manual, and then the number of owners of that particular car. So these are the dataset features. Using these features, we need to train our machine learning model that can find patterns in the dataset and predict that at what price that particular used car can be sold. So now let's see the workflow of our data. So first is a data collection. So we need this car data. So the data set will be fed to our machine learning model. Once we have this data set, we need to pre-process the data. So we cannot feed this raw data into our machine learning algorithm. To understand the data, we need to do some pre-processing step that is called as data pre-processing. Once we process the data, we will split the data into training and testing data. This step is called as train and test split. Then we will train our machine learning model with the training data, and we will test and evaluate our machine learning model with the test data. So we will feed this to our regression model. In this case, we will use two regression model. First one with the linear regression, and then we will use LASSO regression model. And we will compare the accuracy score or error percentage of the model and see which model performs better for the particular data set. This is a regression problem because we are predicting a particular value on which the car can be sold. Let's get into the coding part. So we will be coding in a Google Colab, and I have uploaded the data here, the car data. So I will provide this dataset link in the description. So you just have to right click and then click on upload and upload in this Google Colab. So we will begin by importing the dependency. The dependencies are nothing but libraries which we will be using in our code, in our project. So let's start. Pandas SPD import matplotlib dot pyplot as plt import cborn as SNS from sklearn. We will import the model selection. Model selection. From model selection, we will import a train test split. So import so again from sklearn, we will choose the linear model. From that linear model, we will choose the linear regression. So again from sklearn, Again, from linear model, we will import the LASSO regression model. So from sklearn, we'll import our evaluation metrics, that is import metrics. So that's it. So this pandas we have imported. It is used to create data frames, which will be means the data will be saved in tabular form, which will be easier to process. So this matplotlib and SNS is useful for making plots and graph, and this trend is split, and these two are our model which we are going to use, machine learning algorithm which we are going to use, and finally we will evaluate with this matrix. This one is used for the evaluation purposes. Now let's start loading our data from CSV file to pandas data frame. So car dataset equal to pd.read CSV. So now we will click on this folder and click on this three dot and copy the path. So we'll paste this path here. So this, you can see it's in CSV format. So we are converting it to a data frame format, pandas data frame format. So now our car data set has been loaded into pandas data frame. So now we will inspect the first 5 rows of the data frame. So let's do that. And for that, we will use the head command, head function. Dot head. So you can see that first 5 rows of the data set is being shown. So you can see the car name, year, selling price, present price, kilometers driven, and fuel type, seller type, transmission, owner. So let's check the number of rows and columns of our data set. So we will do that with the shape. So there are 301 values of different cars, and there are 9 in total, 9 columns. So let's get some more information about the data set, and this for this we will use the info function. So car dataset dot info. So we can see the information of every columns, like this car name is a category, it is an object format, that is and that represent that it is a categorical data, and the year is in int and float, and again this fuel type and seller type is and transmission, these are all categorical data. So first we will check is there any missing values or not. For that we will perform this function car dataset dot isNull dot sum. So you can see that we don't have any missing values. So if we have any missing value there, there are also some steps we need to do, like if there are any missing values. So like imputation, we have to replace those missing values with some suitable values. But here we don't have any missing values, so we will proceed. So we will now check for the distribution of categorical data. So we will print data set dot fuel type. You can see that a fuel type, seller type, and transmission. These are the object columns. And this we will require, and the car name is what we can ignore for now, because that will not be used for our modeling purposes. Fuel type dot value counts. So I will just copy this, and as we have 3 such data, so I will copy this 3 times and just change the seller fuel type to seller type. And under transmission, so we are done. So we will run this cell, and we can see that for petrol there are 239 data, and diesel there are 60, CNG there are 2, dealer we have 195, and individuals we have 106. And for there are manual 261 manual and 40 automatic. So all these columns are in text. So our machine learning model cannot understand text. So we are going to convert this text into some numerical values. So we will do encoding. So let's start with encoding process. So encoding is nothing like it's just giving particular numerical value to the categorical type and categorical data. So card data set dot replace. We will replace all categorical value to numerical value. So first one is our fuel type. So fuel type. So that will be there are like we have petrol, diesel, and CNG. Petrol. So for petrol, we will assign it as 0. And we have diesel. For diesel, we will assign it as 1. Then CNG. CNG, we will assign it as 2. So we will close this bracket, and then we are supposed to write in place equal to true. So by writing this, it will permanently get saved in this car data set. All the values will be replaced permanently. So this for fuel type, and the same thing we have to do with rest seller type and transmission column. So I will just copy this and paste twice. So I have to just replace the fuel type with the seller type. So in seller type, we had dealer and individual. So I will copy that. For dealer, we will write 0. And we have individual. We will assign it as 1. And we can delete this. So again, this transmission value I have to take this transmission So there are manual and automatic. So I will copy this manual. Assign it with 0, and the automatic, I will assign the automatic with 1. So please be ensured that make ensure that this all the data which are given in our data set and value you are providing, means like during in this process, it should be the same thing. If any mismatch will cause an error, so you have to be very careful. So now our encoding is done. So now let's check the first 5 data set of car data set. So let's see. So you can see that this we have made changes. We have done label encoding in this fuel type, seller type, and transmission. And you can see the numerical column. Beforehand, it was categorical columns. So now it has been changed to numerical one. So now let's proceed. So now we will split the data and our target data. So for X value, we'll drop the car name. Just I said before that the car name is is not mandatory to keep for our label training. So we'll drop this. Sorry, for our model training. So we will drop this car name, and also the selling price that will use. The selling price is our label column. So we will keep it in Y. So we will drop for selling price in X. So selling price becomes our target and target column, and this car name we can't use for our prediction. So we'll drop that. So now let's check the value of X. So we can see the value of X. Now let's check the value of Y. That's our target column. That is the selling price column. So let's start with the splitting our training and test data. So X train, X test, Y train, Y test equal to train test split Y. Give the test size as let's say we will give the test size as 0.1, and we'll choose random state equal to 2. So we'll run this. So basically we are dividing our data set into X train, X test, Y train, Y test, and this test size is 0.1 means only 10% of data set is taken as for training for testing purposes, and the remaining 90% is taken for the model training purposes. And random state is equal to 2. So that means this is just to reproduce the same code which I am doing. So like if you mention that random state equal to 2, then our your and mine data set will be splitted in the same way, and it's just to reproduce the code. So let's start with model training. So we will first use linear regression followed by the lasso regression. So let's start with the linear regression part. So lin reg regression for model equal to linear regression so we'll fit our model. So lin reg model dot fit will fit our x train and y train. X train y train. So our model is fixed. Now our model has been trained. So now we can do a prediction on training data. So training prediction. So like for regression, we use various metrics such as R squared, mean absolute error, root mean square error. In this case, I will show you R squared metrics, which is one of the evaluation metrics. So R squared statistics provides a measure of fit. Like it generally takes values between 0 and 1, and it in simple words, it represents how many of our data is being explained by our model. Let's say R square is 0.83. That is, it says that our model fits 83% of the total data set. So generally we use accuracy score for classification, and here as it is a regression, the model is a as it is a regression problem, so we will use R square error for evaluation metrics as our evaluation metrics. So let's proceed with that. We'll find the R square. So R score is matrix dot R2 underscore score. So we'll use our Y train here. And our training data prediction. So now I will print my R square value. So we'll use let's not, let's keep it as R score. R score. So let's run it. So our R square value is 0.87. So you can see that it says that our model fits like almost 87% of the total data set. So this is the training data set I am using. So let's try to visualize the actual price and the predicted price. So for that, we will plot a graph, like we will plot a scatter plot. So let's do that. In next level, we will keep our actual price. So just copy this. So for Y level, I will keep it as, for Y level, I will keep it as predicted price. PRAD predicted price. So finally, I will provide a title. So title will be actual price versus our predicted price. So plt.show to display our graph. So you can see that there are not much distance between the values here. So most of the values are closer to each other. So once the price value increases, there is some gap because the price of this car are in the range of 10. Most of the price are in the range of 10. There are very less value greater than 10. That's why there is very less value in this case. But as you can see, the value predicted by our ML model is very close to the original sold price. This is how you can estimate our model performance by plotting the prediction and the original value in case of a scatter plot. So now after doing our prediction on training data, let's do it on the text data. So it's pretty much the same procedure. So we just have to copy this and change the value to text. Sorry, test. So now we are doing prediction on our test data. So we'll change the training to test. So now I will print the R square value. Again, I will copy this R square value of test dataset. So all train will be converted to test. So test data prediction. So yeah, we are good to go. So let's check. So you can see its R square value is almost 83%, which is a very good value. So now we will also plot the same actual graph scatter plot we have plotted for the training data set. So I will copy this. So this scatter plot for the actual price versus the predicted price for a test data set. So you can see the scatter plot. So like linear regression generally works well in cases which are directly correlated or positively correlated. That is, if one value increases, the other also increases. That is it is directly proportional, or it is but when there are multiple features or multiple columns, in that case we use other regression like lasso and XGBoost and etc. So let's uh, do our model training in with the help of a lasso regression. So let's start with lasso. So we will load a regression model. We follow almost the same procedure. So again, we will fit our model. Dot fit with X train and Y train. So now our model is done. Our model is trained with the training data set. So now we will do prediction on the training data set. So we'll follow the same procedure. So I will copy this. So like, and the training data prediction, we just have to change it as lasso, and rest all will be same. So again, we will print our R score. Like R squared value, we will so you can see that the R square value is around 84%. So now let's follow the same procedure. We will plot a graph between actual and actual versus predicted. I will copy this. So this is the graph of actual versus predicted using lasso regression model. So now we will perform the same thing with our test data set. So we'll copy this. So test data prediction, and here our model will be lasso, and rest everything will be the same. So then we will calculate the R squared value. So it's our R square value is coming out to be 84%. with this test data set. So which is quite a good value. So now finally we will plot the graph of scatter plot for the test data set using the lasso regression model. So you can see that this is the graph for the test data set of using the lasso regression model. So that's it. This is from my part. Hope you have enjoyed this video. Thank you.